Hello, I will explain now how to find the height of any object using protractor. Okay, so you have a protractor, you put a weight on the middle, and then you point it to whatever object you want to find its height. So the weight will be pulled down, pulling the string down, and the acute angle you have to observe. So on the protractor it can be 40, 50, 60. Any acute angle will be good. It depends on the height of the building or the height that you are measuring. Okay, so let's say we measured, so a man spotted the top of a building at 40 degrees. Okay, with the vertical. Okay, so this is with the vertical. It is important because it's different than the with the horizontal. With the horizontal it will be angle of elevation. Okay, so it's something else. So he is 40 meters far from its base. Okay, so we have to know also some other information: how far he is from the base, how far he is from the roof, from the top. So you have to have another information in hand. Okay, so the man is 40 meters far from its base. Find the building height. Find the building height. Okay, so we will make little drawing to express this question. We make little drawing. We have a building, and the building of course will be a vertical line, and the man is on the ground, so this is like the ground. Okay, and he spotted, so here is the man in this place. Okay, what did he do? He spotted the top of the roof. He looked at the top of the roof with an angle 40 degrees vertically. Okay, so like I said, it's not with the horizontal, so the angle will be with the vertical. Where is the angle with the vertical here? It will be ending to here, because this is the angle with the vertical. Okay, but how is the angle that is the man spotted ended to be in another place? So how did this happen? Okay, I will show you. If we were holding the protractor like that, okay, so the pulling will be like that. So the acute angle is made with the vertical, between the tilting line and the vertical line, this. So I'm gonna make a little extension to that. Okay, so to show you where was the acute angle in the first place. The acute angle was that was like the string pulled down, and this is like the edge of the protractor. Okay, and the string pulled down with the edge of the protractor made an acute angle 40 degree. The 40 degree was here. Okay, how did it end up to be here? Okay, these two vertical lines are parallel. Any two vertical lines are parallel to each other, right? And this is a transversal between them. Okay, so these two lines are making what we call corresponding angles. So these two angles here, this angle and this angle, are corresponding angles. These two acute angles are corresponding. The angle between the tilting and the vertical here is the same as the angle between the tilting and the vertical here, because it is on same straight line. Okay, so these are two corresponding angles, and they are equal in measure, because the vertical lines are parallel to each other. They are parallel. Okay, so this how it ended to be on the top of the roof. The acute angle not between the tilting line and the horizontal, it is between the tilting line and the vertical. Okay, so in some other questions they can say angle of elevation is 40 degree. So it will not be between the, if they said angle of elevation, so elevation angle will be between the tilting line and the horizontal. If it is mentioned between tilting line and horizontal, it will be here. Or if it is mentioned like between the man spotted with elevation angle 40 degree, it will be between the tilting line and the horizontal. But it's not what we have here. We have the vertical and the tilting line. So this 40 degrees here. Okay, so the man is far from the base of the building 40 meters. So the 40 meters is this horizontal line. Okay, of course any horizontal line will be perpendicular with any vertical line, so the angle here is 90 degrees. After that we will use the trigonometry rules. Depends on what we want to have, what we want to find. We want to find the height of the building, so we have to write the names of these lines with respect to this acute angle that we have. Okay, any line facing the right angle, of course in the right angle triangle, this is a hypotenuse, and so the line facing the right angle is a hypotenuse. Okay, the line facing the acute angle that we have is called opposite, and the third line is called adjacent. Okay, so hypotenuse, adjacent, opposite. Okay, only two of them we will work on. We want to work on only two of them. Which two we will work on? We will work on the one we want and the one we have. We will not work in anything else. What we want and what we have. Okay, what we want is the height of the building. So that find the building height. So this is what we want. So we will work on this one. On the adjacent, because we want to find it. Also, we want to work on what we have. We have the 40 meter, which is the opposite. So we will work on this one. So what we don't need here is the hypotenuse. We will not work on it. So we have two words here, opposite, adjacent. So it is in which trigonometric ratios. We have three rules for trigonometry. So sine theta, cosine theta, and tan theta. Sine theta means sine any angle, acute angle, opposite over hypotenuse. Cosine theta is adjacent. These rules I'm writing them just to remind you or show you they are not a part of the solution, so they are just rules you should know. Adjacent over hypotenuse is a cosine, tan is opposite over adjacent. So one of them only will be used. Is it the sine or the cosine or the tan? It depends. We want to work on these two lines only, adjacent and opposite. So opposite and adjacent, they exist. These two words exist in the tan theta. Tan theta equals opposite over adjacent. So we will not work on the sine or cosine. We will work on the tan rule. Okay, but instead, theta, I will replace it by the value 40 degrees. Theta is the angle 40. So I say tan. Then I write the value of the angle theta. So theta here is 40 degrees. So tan 40 degrees equals, okay, opposite. So the opposite, we know the value of the opposite, so it's okay to write how much it is. So it is 40 meters, so I write 40. No need to write meter now. In the end we can write that. So 40 over adjacent. The adjacent I don't know, so I don't want to write adjacent again, and you can write height of the building or building height. Okay, so how do we get the height of the building? We want to do cross multiplication, so I make this side as a fractional form. over 1. Okay, so the two numbers making a cross, you time them and divide by the third number. So the two numbers making cross here are 40 and 1. So 40 times 1 divided by 10, 40. So the height of the building, so I write what I am finding, height of the building, or building height, equals, so the two numbers making cross, you multiply them and divide by the third. 1 times 40, or 40 times 1, divided by 10, 40 degrees. Okay, use the calculator for that. 40 times 1 divided by 10, 40 degrees. Okay, so approximately 47.7 meter. Approximately 47.7 meter. That's the height of the building approximately. Thank you for listening. I hope it was useful for you to find some application in trigonometry in real life. Thank you. Goodbye.